Hello and welcome back to the lecture on business econometrics. So we are talking about probability theory, and in the previous lecture we spoke about different types of measurement of probability, and one of them is measuring probability even before the event happens, and that we call a prior probability. One approach to look at it is basically classical approach. And before we actually talk about what classical approach to probability is, let us again define some of the terminologies that we are going to use when we're going to define classical probability. Okay. So when we will define this classical theory of probability, we'll be using these terminologies, and let me just write it down. Uh, one term is called mutually exclusive mutually exclusive events. So what I mean by mutually exclusive event is that when two or more event can't occur simultaneously, or occurrence of one event implies non-occurrence of the other. Let me write down the shorter version. Occurrence of one event implies non-occurrence of the others or other events. Okay. So for example, if I am tossing a coin, if I'm getting a head, that automatically entails that I don't have a tail. So that's basically how we define mutually exclusive events. And then we use a term called exhaustive. By exhaustive, we mean when you are considering all the possible outcomes, basically, or it means that at least one of them has to happen. For example, if I am, tossing two coins, so then all my sample space is going to be, say, HH, HT, TH, TT. So this is basically the exhaustive list, and it means whenever I'm, tossing two coins, at least one of these outcome has to happen. So we have to get one of these four possible outcomes. So this is the exhaustive list of outcomes. Okay, and then we will use another term, and that is called equally likely. Equally likely. So the way the term basically, it's quite self-explanatory. It means that equiprobable. So all the events, all the outcomes of a random experiment are equiprobable. So they have equal chance of occurring, right? So outcomes are equiprobable. Outcomes are equiprobable. Equiprobable. Outcomes are equiprobable. So they have equal chance. So no one has preference over, no one outcome has preference over the other. We can also write no outcome has a preference over the others. Okay, so that's what we call equally likely. Another term that we will often use is that cases favorable to an event. Cases favorable to an event. So what it means is, among all the possible outcomes, among all the possible outcomes of a random experiment, those cases which entail occurrence of an event A, those cases which entails the occurrence of an event A are called cases favorable to an event. So basically, what I mean by entailing the occurrence of an event A is, for example, if I'm tossing two coins again, the same example, and my case here is that my event A is at least one head. Say, let me write down at least one head. And if I have, say, all the possible outcomes, TH and TT, so this is my sample space, okay, and if I have at least one head, so that means I have to have this, this, or these, um, that is, which is basically cases. These are the cases favorable to an event where event A is where my event A is at least one head. So let me write down event A is at least one head. Okay, and there are four possible cases. There are total in the sample space we have four possible cases, and whereas three cases are entailing to the this case, this event A, right? Um, So just here, one thing you need to remember, it might appear pretty similar to the definition of random variable. So here you need to be mindful about how it is different. So here, for example, cases favorable to an event. So I'm basically considering all these different cases entailing to that event. So basically, in a random variable also, you have different cases which will, favor, if you define a particular event. So these are the definitions that we need to sort of be familiar with. Now we will get into defining the classical theory of probability. Okay.